Hi, welcome to today's video. Now this is going to be a new series of videos for the MERG LCC / Open LCB SIG. And what I'm going to be starting the series off with is controlling and automating your model railway using OpenLCB. So this will be building on from starting off with something like a very simple shuttle as we see here, which you don't really need a layout command control bus. But when you start building a bigger layout, you probably do need a layout control bus. And in this case, we're using a 2-wire CAN bus network. Now, this could be done just using JMRI and scripting with timing. So you could time how long the train takes and then do it that way. But I'm actually doing it using 4 spot detectors which are underneath the track. They're feeding the signal back to JMRI. JMRI then tells DCC-EX, or my command station, to change the speed and direction of the loco. So now, as you can see here, it's moving along, it's sped up a little bit, slowed down, reached the sensor here and stopped. Now obviously, because I have got LCC, which is the commercial side of OpenLCB, I've now got my mimic panel here, which all you can probably see here is there's a red LED flashing which tells me the train is in that block. Now the block is not actually being used for the automation script, but it all ties in nicely with the whole layout eventually. Now at the moment this train is using what is called the back and forth example within JMRI scripting. So that is quite simple. But I could also add in routes. So I could now tell it, instead of coming up and down here, I could send it around here through the mountain and over into the Peel station. And I could also have another locomotive doing other things. So this is what I'm going to build up over the next few weeks in a series of videos to show you how you can use OpenLCB, and in my case using ESP32 Dev Kit 1s, and the modular approach that I use. So for this to work, obviously I got a reconditioned HP desktop Windows machine that runs JMRI. Here you can see my CAN bus interface, which is the MERG CAN USB 4 kit, which that does my interfacing between my CAN bus, my 2-wired bus here, and my PC. Obviously, here is the block detection. Now, this is not being used for the shuttle that you see here, still working. This here is my DCC-EX, which is on a Arduino Mega with the Geek Robot motor shield. And then obviously here is the rest of my block detection. So that will come in later on in the series when I start talking about using block detection within the scripting as well. And then here you can see one of my nodes. So it's the ESP32 Dev Kit 1 on the shield. Here you can see the small transceiver unit. This here is used for breaking out the inputs, which are used for the small block spot detectors, which you can see in the track here. And then this one here is the MCP23017, which is giving me 16 outputs. So, as I say, in this node here, this will drive 2 servos, 2 frog switches, and then it's got 10 inputs and 16 outputs. So this is approximate cost, probably about £10 depending where you buy it from. You can get it less if you do it from AliExpress, but hopefully this is one of the nodes that is actually being used heavily on the layout. The other node is obviously what I call my basic series, which does not have the MCP23017, as I don't need that many inputs or outputs on it. And then, as I say, for controlling the routes, this is a video which I have shown already, this is one of my nodes. This is again another basic series node, and this one can allow me to change the route. So at the moment you can see it's set for going straight on here. So I could be driving a train along here, but I can't, because at the moment turnout 2 is not set for me to come across and down. So if I want that to happen, I want a blue line. So if I press the blue here, you see there, the LED has changed. So now I know my turnout over here has been changed for me. So while this train is going backwards and forwards, I can then start using my phone and start driving this train. So I could have a nice bit of movement going on here with this train. The important part is you need, if you're going to do automation, you need to make sure your track is spotlessly clean and you don't have any issues, and also that the locomotive is well serviced as well. So these are the keys for successful automation on a layout. And then here you can see the modules I use for the spot detectors. So this one here is how you get it when you buy it. So these will work on 3.3 volts, but what you'll see here, this clear LED will get light bleed from the side if you're not careful. So what I tend to do is I paint the clear LED around the sides black, but I make sure I keep the top of it clear. So that then picks up underneath the wagon here, and under this loco has been painted white, so it guarantees it does pick up the signal. And then because I'm using 1 inch of foam and then the cork bed to the track, I then made a simple mount that allows me to push it up through. It just fits nicely between my sleepers. I do have to do a little bit of fettling, but that's not too big an issue. And then a screw underneath, and then the 3 wires. So you supply 3.3 volts, and in my case I don't supply the 3.3 volts from the shield, I supply it from my PC power supply. And I don't mean the one here, I have another one which is underneath, which is this one here. And then we just take the data cable into one of the screw terminals here. Now I tend to use Cat5 cabling, and that works nicely for that. So the node I showed is running this one, which is the 2 servo 10 in 16 out, and this is my GitHub repository. And within the repository I have a wiki feature which is here, and here you can see I've started putting a lot of the documentation together, for the servo control side of it, the block detection side, and infrared spot detection. So it's worth keeping an eye on this repository for as I progress it. To get hold of the code, what I suggest you do, rather than using the green button here, is go to the releases, and this ensures you get the latest release that I've done rather than something that I may be working on. And then if you click here, it opens this here, and then what you've got then is you can choose whether you want a zip file or a tar file. So that's how I'd recommend you get hold of the software. Obviously you will need the OpenLCB single thread library as well. This has all been documented before, but I can go over that if people wish. Please leave a comment in the video and I will make sure I cover these things if I've missed anything already. So once you've downloaded the software, once you open it up in the Arduino IDE, so here you'll notice I'm using the IDE as a 2.3.10. So once you've installed the OpenLCB single thread library, and just to recap how to get hold of that, so LCC, then if you scroll down you'll see here is the OpenLCB single thread by David Harris and Bob Jacobson, and at the moment we're on version 0.1.19, so you've got to have that installed before you try and run this software. The only thing that you have to alter is, depending on the MCP, obviously, you know, I've got this and it's using address 20, but you know, if you have something different, then you may have to change something within this code. So to use this on a CAN bus system, you do need to have your own unique address for your nodes. So when it comes, this is actually my personal number, and then it's address 01 for this node at the moment. And then you have another setting here, which is, you know, reset to factory. This should come as 1 when you first get the node. So once you put in your unique ID, MERG members can use their address or their membership number if we wish. I have got a video available for that, so I can make that available as well. So once you've got it set up, all you do is make sure you've set your board. So I use this method here, so boards, ESP32, choose dev module, and then also make sure you've got the COM port set up. So in this case I'm on COM port 9, so you'll see it's appeared here. You can then compile it and upload it to the board. Now this will take a few, on some machines it's a little longer, it depends on your machine. Obviously it'll compile it, and then once it's compiled it, it will start uploading it to the board. So you'll then see the message here to say hard reset has been done. You will notice on your ESP32 the blue LED, or whatever colour your LED is on D2, will light up. You then go to here, you set it to 0, recompile and upload it. Now you've got to do this because if you didn't do the 0 part, it will not save any changes you make within JMRI. So once this is complete, we're ready to go in and connect it to our JMRI setup. The other thing I forgot to mention then is there are a number of third-party libraries that you will need. So we use the ESP32 servo.h, obviously the wire library, and in this case the MCP 23017. So it's important to go into here and then type in, so for the ESP32, and it's servo, and you'll notice this is the one that we're working with, which is Kevin Harrington's, and it's at version 3.2.1. so that's important to have that one installed. And the other one for the MCP 23017, we're using this one by Bertrand, so this one is at version 2.0.0. so again that will need to be installed for this sketch to work. You will also notice here for the frog relays we're using pins 25 and 26, and the servos are on pins 32 and 33, and that's about it for the code really. These are the pins that we're using for the inputs, and then obviously for the outputs they are all on the MCP. So as I mentioned before, if you're using a different MCP and it has a different address, you would need to change this here. I'd recommend using the one that I've shown here, which has got an address of OX20. Then the only other thing I will mention, if we go to the board manager, because it's important to make sure you're using the same versions as we are using, and we type in ESP32, you'll see we've got either the Arduino ESP32 boards by Arduino. Now even though I've got this installed, I'm not using this version, I'm using the version by Expressive, and I'm using the version which is 3.3.11. So as long as you've got these, this is what we've been building the nodes on and testing them on. I'm actually using a Windows 10 machine and a Windows 11, and I've also tested the sketch with a Linux machine running Mint. So hopefully this has shown you some of the things. I'll just show you quickly what the node looks like in JMRI. So I'll quickly go through As you can see here, it says I've got an LCC using CAN via MERG, CAN RS or CAN USB on COM port 8. So to do this, obviously we go to Preferences. Obviously you've got to create a connection. I've already done it, but if you went to here it would say, well, what do you want to connect up? So you scroll down, say it's an LCC. Obviously it's saying, oh, you've got something already similar, so I won't keep that one, I'll delete it anyway. So once you've chose LCC, scroll down, you go to the MERG via CAN USB 4. Obviously that node I showed can be used as a standalone module, and that's quite easily to set up if you wanted, but I'll cover that in a separate video. So once you've got that set there, you've got to tell it what port it's on. So you tell it on COM port 8. You don't have to do anything else, you just click on save. It'll say I want to restart, so I will restart it anyway. And then when we go down to here, we've got configure nodes. Now I'm using Panel Pro. You can use the LCC Pro version if you wanted. I just find Panel Pro easier to work with myself personally. Anyway, we go to configure nodes, and then here you can see you've got the 0201. This is actually JMRI, which is seen as a node on the bus. And then we've got my node here, and you can see the details we've got about the node, and it's telling you the software version of the node is actually running version 1.0.4. The 071 is to do with the library that we use. I could actually remove that quite easily within the sketch if I wanted. But if we go here to Open Configuration Dialog, here you can see now JMRI is talking to the node to get the details from the node, so it will create the CDI for us. So here you can see we've got the node name, which is saying ESP32, and the node description. You can change these to what you like. This one you've got 19 characters to play with, and this one you've got 23. When you change them, click on the right and that will save them. In this particular node we've got the speed. For slow motion, really I find 5 is the best setting. So you can change the slider. It automatically saves for you. If you've signed, sometimes some things don't save. You'll see down here it will tell you you need to save changes, so you can either click down here or up here. The best thing I will always advise people, so I should have done this first, is whenever you get the node, when you first set it up, make a backup of it to a place where you want to save it. So if you make a mess while you're configuring the node, you just then restore it. That saves you a lot of time having to re-upload all the sketches again. So again, here you can see we've got 2 servos. Servo 1 is on pin 32, servo 2 is on pin 33. Give it a name that you like, 23 characters. Now if you're on a Mac, this closed, mid and throne will be over here. I can't do anything about that because we use position 1, 2 and 3. So I would recommend position 1 you used as closed. And then what you've got here is an event that you can use to teach your JMRI or other nodes. Also inputs from either this node, because it will consume its own events, or from another node. You can actually send this event number and the turnout would be moved for you to its position 1. Obviously when it comes, they will come with the value here set to 90 to allow you to set up your servo and your turnout. Please be careful if you're going to use the slider. Obviously when you're first setting it up in position 1, if you move the slider, the servo will move. I normally recommend, depending on how you put your servo, if you're going anti-clockwise, the number will go smaller, but I would first start off typing in, say, 85 into this box here. Obviously it won't do anything until you click right, and then it will move the servo, so at least you can see you're going in the right direction and seeing the amount of movement. If you're working in N gauge, I'd only move it maybe to 87, if that, So be careful. If you click on here, you can now use your up down arrow keys to move them slowly in the direction you want. Now what you'll notice there, it's automatically saved because it knows you're working with the slider. Then what we've got here is 4 more events associated with the servo or the turnout. So I've got an event here to say the servo has reached its closed position or position 1, another one for the thrown position, and these just automatically will appear on the canvas when you move the servos. Then we have the 2 frog switching events. Now I'm not actually teaching these events to the inputs, to the outputs. This has been hard coded, but these can be handy for other things on your layout, how you want to use it. So they're there if you wish to use them. So here you can see we've got the 8 events or the 8 inputs that are available on this module, which are on pins D4, 16, 17, 5, 18, 19, 13, 12, 14 and 27. Again, each one you can give a description. Now I've only given you 2 options here, so we've got the direct state tracking, so a sensor or a switch. We're using input with pull-up because it uses the weak pull-up on the ESP32, or the other option is to use a push button and use a toggle state change. I've then got 2 delay features here that you can use if you want to do a delayed thing. Now I do actually use a delayed state for the spot detectors, so when the train moves off the spot detector I put a delay, and I think I've used 10 as a value in this one here, just to slow it down so you don't get sudden a lot of events firing onto the bus. Obviously these are the events that you would use. Now because the infrared sensors, when they see something they go high, so they're 3 volts, so you've got to choose which one of these you're going to use. I'll go in more into detail on that when I actually go into it, so I can show you me actually setting one up. Then the outputs, we've got the MCP 23017 telling you what address it's on, and then these are the different channels that you've got available. And then if you want to drive an LED high you can use this event here, if you want to drive it low you can use this event. So hopefully that gives you an insight to the node that I've shown that I am working with the spot detection. But as I say, I will go into more detail showing you me setting that up and using the teaching events for JMRI in the next video. So as this is a MERG video, what I would suggest to people is when you're starting to build a model railway, it's important to learn how to solder correctly. Now, I personally use leaded solder 6040, well ventilated room, and always wash my hands thoroughly after using. I find I get nicer soldered joints, and that is critical when you're going to solder something. I'd also recommend you start off on something very cheap that you're not really overly worried if while you're learning to practice to solder. Obviously within MERG we do have area groups, and lots of these do offer people to help you learn to solder if you need to. Having a good soldering iron with variable temperature control is really going to help you, but be prepared, some of these cheaper ones are known to read not correct, so you might think you're doing it the right temperature and you might find that your iron is actually 20, 30, 40 degrees higher, which can damage components. Now, the reason I'm talking about soldering is because we use one of the MERG kits to give me a PC interface, I suggest people would learn to solder. That gives you a cheap way into it. Yes, we are looking at showing you a commercial device that's available quite cheaply, but that's further down the line. Or of course you can use some of the commercial LCC products like the Sprog LCC USB or RR circuit. But with those, you will have to break into the Ethernet cable connections. Now, because the way I'm doing it with the ESP32, two CAN bus cablings, it is also important to make sure you've got the right termination resistors on the system, especially even on this layout, which isn't that big compared to some of the American ones. You know, it's important to follow the specifications for the wiring to get a successful, layout. So if you're going to go into it and you're going to build a CAN USB 4, if you can solder and you're an electronic expert, or you can look at a circuit diagram or a PCB and work it out, that's fine. However, when you look at the build instructions, you normally get that come with it. There's only a few pages. There is an excellent guide or build guide available that goes through step by step on how to build it and how to test it. And these really are very helpful. Now, the team behind who put that paperwork together have made a fantastic job, in my opinion. So, learning to do soldering, yes, it makes life a lot easier. Yes, I am doing it with DuPont connectors on my modules, which makes them easier. And people might say, well, why aren't I using a PCB? I don't feel I need to. Maybe in the future we'll make a PCB available that you could just plug in units. But at this point, now it's about starting to show you just what is possible. So the people, you might say to me, well, John, you could do all this with DCC-EX, and yes, you could. This is only 8 foot by 4 foot, this section. So a I2C bus interface for all this would work. But once you start spreading it out around the whole loft or slightly bigger, I2C can sometimes cause issues. Yes, we can extend it. Previously, this was all done using JMRI and the RS485 bus. Obviously, I've learned the new technique in using a CAN bus. Hopefully, this now will work the way I want it to. There was a little bit of latency with the fact that the PC would have to poll as I added more modules, and the fact that each one would have had inputs. So the computer has to tell JMRI, now poll the node over here, now poll this one, this. Where with this, it's event driven. So when the ESP32 sees an input do something, it sends the message out on the bus. So that becomes, excellent way of doing it. Also, CAN bus is very noise tolerant, hence why it's used on automobiles and other things. So, I think it's a good way to people to look at in the future. Anyway, I think that'll do for today's introduction to what the series is going to show you. And in future, they'll be broken down into small sections to show you how I've gone about each particular part on the layout. Okay, thanks very much, and enjoying seeing this train moving back and forwards while I actually work in the loft.